All right, everybody, welcome to subnetting. So subnetting is something that you'll run across if you get into the IT field, but more specifically, if you get into the network side of things, specifically, like network administration. You will run across this in the Network Plus exam. You'll most certainly run across this in your any Cisco certs that you do, such as your CCNA. And subnetting can put a little bit of panic in people. But if you can grasp some of the fundamentals, which we're going to go over today, then hopefully it'll be a little bit easier for you to dig deeper into subnetting. So let's start off with some basics first. We're going to go back to grade school. And the system that we learned in grade school is the base 10 system. And one of the ways they taught base 10 was through place value. In place value, you could have a number like this, 3742, but because of their place, it would be 3,742. Fairly basic, fairly easy to understand. Now, you might be asking yourself, why are we going back to grade school, and why are we exploring the base 10 and place value, just system and everything and how that works? Well, I'm actually laying some groundwork, so bear with me. All right, so you got the place value system, base 10. This is what we've learned in grade school. Computers don't use base 10 though. What do they use? They use a system called binary. What is binary? Well, binaries are ones and zeros. And side note, a little bit of history, they did ones and zeros because basically computer data, any information that's going through a computer, is done so through electrical current. And the processor is translating that electrical current into data that you see on the screen. It does so by ones and zeros. What do the ones and zeros mean? So 1 means on and 0 means off. It's like a light switch. And so it's getting a form of Morse code through the processor, and it's translating that on off into ones and zeros, which eventually means something. And it stores those ones and zeros into a cache, and then is able to convert that into meaningful data. But what does that have to do with, the base 10 system, place value, and all that? Binary is built off of the base 2 system. And the base 2 system looks like this. So you have 1, then you have 2, and then you have 4, you have 8, and then you have 16, and 32, 64, 128. Excuse me. And this goes further, of course, 256, 1024, et cetera, et cetera, et cetera. And you might recognize some of these numbers, such as, 8, 16, 32, 64, 128, 256, hard drive sizes, RAM memory, resolution sizes. They're all built on the base 2 system, binary, in order to provide you with memory or resolutions, etc. Because let's say the resolution pixels are little bits of information on and off, and that is how the computer translates the electrical current into what you see. So the base 2 system is built something like this. So let's say we have a number that we want the computer to create. So let's say we want to do 33. So we get as close to 33 as we can, which is 32. And then 16 is too far, 0 is too far, 4 is too far, 2 is too far, but one more would make 33. So in the computer's world, 1, 0, 0, 0, 0, 1 is 33. Let's do that again. Let's say we do 192. We want to build 192. What would we do? Well, we'd get as close to 192 as we can. 256 is too far. 128 is close. How about 64? Well, let's see. 64 plus 128 just happens to be oops. How about 64? Let's see. 128 plus 64 happens to be 192. Then, of course, since we've reached our goal, we write zeros that way. We don't need to write zeros off to the left-hand side because that would just be infinity of zeros. And so it starts at the first one. All right, so this number, 128 plus 64 equals 192. And then, of course, you have zeros. So the binary number for 192 is 1, 1, 0, 0, 0, 0, 0, 0. All right. So you have learned the basics of binary and how that equals into actual numbers. And we won't get super deep into binary and, bigger numbers and letters, etc., because it actually has a code for, certain letters are, certain ones and zeros, etc. Done. All right. So that's basic binary. What does that have to do with subnetting? Well, this was a good foundation. We're going to get back to this in just a second here. I want to show you binary so that we kind of keep that in the back of your mind and we can move on. All right, so let's get into actual subnetting, what that means, IP addresses, etc. So first off, let's go back to basics. A, B, actually, do it this way. Class A, B, and C. Of course, then you have D and E classes of IP addresses, but the ones in industry are usually A, B, and C. D and E are used for different things. All right, so you have class A, B, and C IP ranges. So these are IPv4 addresses, not IPv6. IPv6 is an entirely different animal. It uses hexadecimal, which is the base 16, which means that everything by the power of 16. IPv4 uses base 2, which is everything by the power of 2. So we're going to stick with IPv4 for this particular lesson because that's where you do your subnetting is IPv4. You don't need to do subnetting for IPv6. There are just so many addresses available that you don't need to do that with it. So with IPv4, class A starts technically at 0 and goes up to 127. Whoops. Wow. Then you have your class B, which goes 128 all the way up to 191. And then your class C, which goes 192 all the way up to 255. Wow, I'm tired. Then you have your class C, which is 192 all the way up to 223. And again, this is the first IP number that you'll see in an IP address. We call that an octet. I'll get into it later. All right, so class A range could look something like this. Let's say 1.5.6.97. Or if you want to know a cool IP address, go to 8.8.8.8. That is a class A public-facing IP address, and that'll take you to the Google site. All right. So this is the class A range, class B range, class C range. Because they had so many IP addresses, they broke it up into sections called ranges. And then within those ranges, they made sections that were public-facing IP addresses. That means the device could be accessible from anywhere on the internet, such as the Google server I just showed you, versus private IP ranges where those devices are not accessible to anywhere on the internet. They're only accessible within a local area network or LAN. And those ranges are in the Class A, you have 10.0.0.1 up to 10.255.255.254. And then the Class B range, which it's a little odd, at 172.16.0.1 to 172.31.255.254. And then Class C is 192.168.0.1 to 192.168.255.254. All right. Excuse me. All right, so these are the various IP ranges here, and then these are the public or the private IP ranges for those particular classes. And within each of these private sections, you have so many IP addresses that are available, such as up here in the Class A range. The Class A range has over 6 million. It's like 6,777 and something IP addresses, 777,000 something IP addresses available to the private range. Whereas down here, the Class C, the 192.168, etc., only has 255 or 254 available hosts. And we'll get more into that later. So 254 available IP addresses down here for this particular class, and over 6 million, close to 7 million IP addresses available in the Class A range. So generally, in the networking world, you're going to usually see either the Class A or Class C range. Class B is not seen as much. It's kind of hard to deal with IP ranges within this specific section. I mean, really, you do have quite a few IP addresses available, but it's just harder to remember and a little harder to dish out IP addresses because of the range that's been specified. So usually, you end up with Class A or Class C. Class C is mostly used in small office, home office, or SOHO routers. You'll see if you plug it in, plug your computer in, you'll eventually get an address that's 192.168. something. Again, this allows you about 254 devices to be plugged into that network, be it wireless or physical, which is quite a bit for a home office or home or small business type scenario. So in an enterprise level network, you're going to see usually the Class A range because it has over 16 million. I think I may have said 6 million before. It's 16 million available IP addresses, over 16 million available IP addresses in the Class A range. So way more than the Class C range, which would be more than sufficient for any business of pretty much any size. And so that's why the Class A is most popular. And so we're going to skip Class C right now. We're going to focus on Class A because we're going to talk about subnetting with an enterprise level IP range. And it's easiest to do so on a Class A range. And again, the private range within Class A IPv4 IP range is the 10. So it's 10.0.0.1 all the way up to 10.255.255.254, or 255. 254, we'll talk about that a little bit later. All right, so this is what we're going to focus on right now. So let's build a scenario. You work for a company that is developing their network. And they come to you as the network admin and say, okay, I want you to build our network. We've got, over, 500 devices on our network, and we need to, get them all connected. Done. Sharing information, etc. So you decide to use the Class A private range because, after all, the Class C range only allows for, let's say, 255 or 254 devices on the network, whereas the Class A range allows many, many more. All right, way more than what you need, but, it's okay. All right, so with the Class A range, let's see, I think it's 677. Let's see. Excuse me. All right, had to look that information up to get the exact number. So 16,777,216 available IP addresses within the Class A range. And you think, whoa, that is way more than what I need, but that's totally cool because it's more than the Class C range, and I don't really like the Class B range. It just kind of looks weird. And so I'm going to stick with, because I have OCD, I'm going to stick with the 10 range. Not really knowing why exactly. All right. So then you have devices that begin to plug into your network. And so let's say you have an HR employee computer and it gets a 10.4.16.25 IP address. And then you have a server for their file system, etc. And it gets an IP address of 10.16.26.72. And then you have Wi-Fi setup, of course. And let's say somebody's phone connects and gets a 10.25.16, I like 16 apparently, .80. And then somebody brings their laptop in, connects to the Wi-Fi, and gets 10.30.25.80. All right, so this is your network right now. You as the network administrator, you look at your network reports and you begin to see these IP addresses kind of bouncing all over the place. It is like the Wild West. Everything is up for grabs. Everybody's grabbing IP addresses left and right. There's really no organization. It's all helter-skelter, and you think, well, I guess that's okay because everybody's getting IP addresses and everything is okay. Then you begin to realize a problem. You have an employee computer, you have a company server, and you have somebody's phone. You also have somebody's laptop they brought in. They're all getting Class A IP range. You think, okay, well, that's okay. But the problem is this Wi-Fi laptop can access the server. So can the phone. They can also access the HR computer. They found them on the network, and they can actually begin to access some of the resources on those particular devices. And you have a scary moment realizing that if this individual with a Wi-Fi laptop or even the Wi-Fi phone has the ability to hack into systems, they have unrestricted access to company resources. So you need to somehow control the devices that are on your network. You need to separate them. You need to organize them. Somebody also installs a printer. And of course, it's also accessible from somebody's laptop. And they begin to print lots of stuff off of that printer. That's a company printer. So you're beginning to see some issues that are popping up because your network is just, it's free range. It's open and wild. Anybody can do anything. Anybody pulls an IP address. You think, okay, how do I begin to organize things? Well, you could go through and begin to do, let's say, MAC filtering and that sort of thing, but it's going to be very time consuming and very expensive as far as your resources go. And then you've got to maintain that. And you've got to maintain some sort of security, but then again, these devices, a lot of them are still going to see the other devices on the network. So what do? Well, the best way is to begin segmenting or segregating your network. So that way you say, okay, that HR employee computers, let's say, are on their own network. Servers are on their own network. Printers are on their own network. And the printer is only accessible from employee computers. And the server is only accessible from employee computers. And the Wi-Fi devices do not have access to internal resources. And they can't even really see each other on the network, but you can specify that later. But they certainly don't have access to internal resources. And so the using network segmentation or breaking up your network into logical chunks like this is where you would begin to do subnetting. We'll get into that in just a little bit. So keep in mind, you can actually organize this up here by sectioning off parts of that network. So this is one giant network. It's open range. It would be like living in the state of California and having Amazon ship you a package. You live in, so we're going to use, let's say, an IP address, the HR computer for an example, 10.4.16.25. Okay, so the 10 represents, let's say, the state, and the rest is your house number. So you live in the state of California, and your house number, let's say, 41,625. So let's say that's your house number. The postal system, the delivery system that delivers the Amazon package to you has to know where exactly 41,625, that house, resides. They know it's somewhere in California, but where exactly, it's up to them to figure out. So in subnetting, what we do is we begin to break things up into logical chunks. We say, okay, we're going to break up the network a little bit. We're going to utilize, let's say, the first 3 numbers in the IP range as a network address. We're going to say this is the state, this is the city, and this is the street, and this is the house number down here. Excuse me. Done. So all employee computers are going to have the first 3 IP addresses, let's say, in their particular network address. So they're going to be 10.4.16, and then whatever their IP address is for their particular device. So let's say this HR computer is 25, another computer joins, it's the business services computer, it's .15. But they all have the 10.4.16 network address. We've taken this giant network of just 10 and we've broken it up and said, okay, this whole section right here is network address. All right. Now with that in mind, let's get into what an IP address is, what it looks like. An IP address is an identification number on a network. It's so that way network devices know where your particular house lives. And if it has a broken up network, a subnetted network, it knows that there are certain separate networks that different devices reside in, such as printers, such as employee computers, servers, Wi-Fi devices, etc. All right. So an IP address, an IPv4 address, is going to be comprised of something like this. Done. And again, we can specify however many numbers are dedicated to network portion versus host portion. And in a 24-bit subnet, I'll get into what that means later, we're going to dedicate the first 3 numbers to our network, as we just showed. And so if you were on a network like that, you would see something like this. Oops. You would see something like this. If you ran an IP config, or if you went into the network adapter services, the properties, you would see something like this. So this would be your IP address, this would be the subnet mask, and this would be your default gateway. And the default gateway is always going to have the 1 at the beginning, indicating that it's the first one on the network. It's the one that's contacted for information. All right. So looking at all of this information, this is probably something you've seen. If you're on your home network, you're probably going to see 192.168.0.15, and its subnet mask is going to look just like this, 255.255.255.0, and your default gateway is going to be 192.168.0.1, and that's going to be, let's say, your router. In this case, because we're using the Class A private range, we're sticking with 10. So normally, to kind of tweak you a little bit, to kind of throw you a curveball, so to speak, normally this is what the subnet mask would look like in a Class A private range. So that brings me to the point of, what does the subnet mask mean? What does it do? What is its purpose? So the subnet mask, in simple terms, tells network devices where the network portion is located and where the host portion of the IP address is located. And so when we want to say, I'm going to use the first 3 numbers in an IP address for network use only, again, let's say state, city, street, I need to mask off, and we'll get into what this looks like in just a second, a portion for networking. So when you see 255, you know that section is completely blacked out for a network address only. Side note, the first number in an IP address is always going to be blacked out. Excuse me. Because that is always used for a network address. All right, so what does the subnet mask mean? What is this 255? What does it mean? We're going to zoom in a little bit on the subnet mask. All right, real quick, before we do that, we're not going to zoom in just yet. IP address, let's say 10.4.16.28. Each of these numbers, and we'll get into what this means in a little bit later, each of these numbers in their particular position is called an octet. This is an octet, that's an octet, that's an octet, that's an octet. So when you hear this phrase start to get used, don't let it throw you. All right, again, we'll get into what that means in just a second. All right, so let's go back to our place value. This is where things begin to get kind of cool and make a little bit more sense. So 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 32, 2 times 32 is 64, 2 times 64 is 128, 2 times 128 is 256, etc., etc. We're only going to go up to 128. Why? This is where the name octet comes in. How many columns do you see? 1, 2, 3, 4, 5, 6. Wow. Start that all over. All right, let's go back to place value, the binary system, the base 2 system that we learned earlier. When I was doing place value, now it's going to start making sense. This is where it gets kind of cool. So we start off with 1, and then we have 2, then we have 4, and we have 8, because 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16, 2 times 16 is 32, 2 times 32 is 64, 2 times 64 is 128. All right. And we're not going to go 256, etc. Why? This is where the term octet comes from, because how many columns do you see? 1, 2, 3, 4, 5, 6, 7, 8. 8. The name octet refers to 8. So an IP address, subnet mask, etc. Done. So an IPv4 IP address is a 32-bit IP address. Okay, it uses a 32-bit range. And what do I mean by that? So when we write an IP address of, let's say, 10.16.32.24, let's say, how many numbers do you see? 4. You see 4 numbers. In each of these octets, you have 8 columns. 8 times 4 is 32. Okay. So in order to make the number 10, let's say, we'd get as close to 10 as we could. 8. 8 plus 4, nope, too big. 8 plus 2, perfect. And obviously we don't need the 1. So 10 is 1010. Okay? And of course 16, we do the 1 there and a bunch of zeros after. And then 32, same thing, 1 and then a bunch of zeros after. And then 24, we'd get as close to 24 as we could, and then we'd begin to build up to 24. This is how binary works. This is how it gets its numbers. All right? So this is just setting some base ground rules so you understand why we call it octets, why it's a 32-bit IPv4 range. All right, now let's get into the subnetting part. We're going to disassociate ourselves from IP addresses right now because mathematically, IP addresses don't have anything to do with the subnet mask. So for instance, we have 10.4.16.32 with a 24-bit subnet range like this. Mathematically, this number has nothing to do with the subnet mask. The subnet mask is there just for network devices to know what section is for the network and what section is for hosts. Okay? So let's disassociate ourselves from IP addresses for the moment. We're going to zoom in to a subnet mask. We're going to zoom into what these 255 numbers mean. All right, kind of setting up some stuff here. Okay. So yes, these little dots represent the dots between the octets. There are 8 columns in each octet. Tell you what, let's put this right there so it's a little less confusing. There are 8 columns in each octet. And if we go back to place value, this is where it's easy to see how binary works. All right, so what does 255 mean? If you were to add up all of these numbers in one of the octets, 1 through 128, guess the number that you would end up with. If you said 255, you're correct, because 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 is 255. Excuse me. And so what that means in networking terms is this is telling network devices the first 3 octets in an IP address are for network use only by saying all of these columns contain ones. They're all in use. They're all active. They're all true. They're all being used by the device to signify that it belongs to a particular network. So when you see 255, it's 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. So you get 255. Same thing here, 255. And again, we won't do the first octet because, like I said, that is always going to be blocked off for network purposes. All right. And then, of course, our 0 down here is just representing this guy up there. That says we can have 254 available hosts. On a side note, what do I mean when I say 254? Why not 255? Because there is an octet that way as well, with the same column, 1, 2, 4, 8, 16, 32, 64, 128, on this side as well. So why do I say 254? Why not 255? Because in networking, the last IP address is always used for broadcast. So 255 is always used for broadcasting. So what do I mean by broadcasting? Well, that would be if I were to ping, let's say I have an IP range of 10.4.16.1, and it's a 24-bit range, by the way, CIDR notation. /24 means 24 bits in use. If you count them, you know that there are 8 here, 8 in use here, 8 in use here. 3 times 8 is 24. So 24 bits in use. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you know, counting the ones all the way down. 24 bits in use. In a 24-bit range, that leaves the last octet available for hosts. And you know that there are only 255 available numbers, right? So there should be 255 available IP addresses. Well, again, the last number is always used, 255, is always used for broadcasting. So if you were to ping 10.4.16, 10.4.16.255 on a 24-bit range, it would ping every IP address in the 10.4.16 range. All 254 hosts would get pinged, and then you would get a response from all of the hosts. It sends out a broadcast saying, everybody available on this network, please report in. And that's what they do. They all report in. And so that last IP address is always used for broadcast. So that's why we have to subtract one IP address from your range. So instead of 255 available hosts, which you would normally have, you really only have 254 because the last IP address number is going to be used for broadcasting. All right. So in this case, we have 254 available hosts because we've used up 24 bits on off, that's what a bit is, in these 3 octets. Done. All right, so when we subnet, we actually come in and we hit the subnet mask and we say, okay, we're going to change, because a normal class A private range is 255.0.0.0, allowing for over the 16 million available IP addresses. When we begin to subnet that network, when we begin to break it down and section it off into logical, organized IP ranges, we can do something like this. We can use a 24-bit range and say, okay, I'm going to block off the first 3 octets and only give myself 254 available IP addresses. Now, let's say that works great. Let's say this is a printer subnet, and you've got roughly around 240 printers. You're good to go. That's a perfect subnet for the printers. And then company expands, and a bunch more printers are purchased, and you suddenly have 300 printers. What do? Well, you've only got 254 available IP addresses. So what are you going to do about it? Well, you would begin to dive into your subnet range a little bit. You know what? Let's back up. Let's scratch that whole section about printers. All right, so you can begin to see how we've broken up this giant network into manageable chunks, into organized chunks. So where, let's say, this particular network range has 254 available hosts. So the network is always going to be 10.4.16 for particular devices. So let's say we have something that looks like this. .4.16.1 for, let's say, employee computers, PCs. And then we have 10.4.17 because it's the next range. We've already used up 254 available hosts up here. We need to move on to the next range, which flips that number over. It's kind of like an odometer on the car. As you begin to use up numbers, it's going to start flipping the other numbers. And so we've used up, to 254, let's say. And so that used up that range. And so we need to move on the next, which is 10.4.17.1 to 254, let's say, for printers. I'm going to try not to write over my other numbers here. We can actually get rid of this number. Do this right now. All right, and then we've got, because we've got 254 devices in use, 10.4.18, because it's the next rolled over number. Here we go. And let's say just for servers, okay? All right, so now you have network segments. The servers reside on the 10.4.18 range. Printers reside on the 10.4.17 range. PCs reside on the 10.4.16 range. So that's how you begin to break up your network. Manageable. And you can actually attach security policies now to those networks because they're their own little network. On that note, the term network refers to the overall network that you have, all of the devices interconnected to each other, regardless of how they're organized. It's every device that's plugged into the network that connects them. You have the internet, which is a giant network, but then you have small networks like this, where you've taken a giant IP range and you've broken it down into manageable chunks. These are basically virtual networks within your giant network. And so that's what I mean when I say network. Don't let the term throw you because it's overused and means multiple things. So we have smaller networks within our giant network, and these smaller networks can now be managed. We can add security policies to them, etc. All right, we're doing good. We run into a scenario. We've got 250 printers, let's say. That's just perfect because we have 254 available hosts for the printers, the printer network. Company expands, and suddenly you have 300 printers. What do? Because now you've got way more printers than you have available IP addresses. So you need to do one of two things. You might need to add another IP range, I guess, and call this printer 2. And we call this one 1. Then you get Wi-Fi devices that connect. Let's say there's going to be a point to all of this. Wi-Fi. And then suddenly you get way more, because the company has grown, you have way more printers, you also have way more PCs. You have like 500 PCs now, which is double, more than, little under double the amount of available IP addresses that you have. Now what do? Do you create another one? Do you come down here and you go 10.4.21.1 to 254 for PC2? And we'll make this PC1, I guess. Okay, you can start to see some of the issues you as a network admin will run into if you start doing your subnets back to back like this. The whole point of this little side venture, this little rabbit hole that we just went down, is organization, because you will need to know how to do basic organization of your subnets as you create them. All right, so in order to skip the mess that's beginning to happen here, this is what you could do. Let's eliminate this. Let's eliminate this. Okay. Give yourself some room between subnet ranges. You can do that. You can actually say, let's say 10.4.10 for the initial PC range. And then you could do 10.4.15 for the printer range. And then 10.4.20 for the server range. And then 10.4.30 if you wish. Not going to have that many servers, but let's just stick with this. Do it by 5s. Okay, for Wi-Fi, let's say. As an example, you can see how you've got some space now. And so potentially you could do 10.4.11.1 to 254 for the next PC range if you wanted to. However, there's a cooler way to do subnetting. This just kind of gives you an idea of how to organize it, some of the problems you might run into, and why you need to subnet in different directions. Okay, this is what I mean by that. All right, so keep in mind the PC situation we were talking about where your PCs have grown to 500. All right, it is your PC range up here is a 24-bit subnet range. Okay, that means that you used up, like down here on our place value column system, you've used up 24 bits. That gives you 254 available IP addresses for hosts. Problem, we need over 500 now. So what do? Well, one of the ways to do that is to tweak our subnet again, and we come in and we say this. I'm going to write out. My blue pen is starting to go out. I'm going to write out, these on this side as well. I switch pins because my other pen is starting to dry out. This one is not looking any better, but hopefully it's a little darker. Okay, so we have full 32 bits in front of you here. Again, the first octet is always going to be solid. 8 bits used up, can't use it. All right, but instead of 24, so 8 plus 8 is 16, plus 8 more is 24. Instead of 24 bits in use, let's make it 23. What happens when we make it 23? Well, guess what? Remember on the 24-bit range, when we used up the last number, the 254, moved over to 255, and then we needed to use the next range, this would flip over to 11, right? Okay, when we are doing all of our subnets out there, the ones that were back-to-back, you had the 10.4.11.1, 10.4.12.1, because you'd utilize the 254. When it would roll over, it would move this. Same thing applies here. So what we've done is we've just given ourselves another 255 available hosts. So with a 23-bit range, it goes from 10.4.10.1 all the way up to 10.4.11.254, which equals us about 511 available IP addresses, because we just doubled the amount, because this down here is equal to, well, 254. This right here is also equal to another 254, because the way it works is we go 10.4.10.1, 2, 3, 4, 5, 6, 7, 8, all the way up to 255, bing, turns over 10.4.11.1, 2, 3, 4, 5, 6, 7, 8, 254. And so that totals about 511, 510 available hosts that you can put on this particular subnet. Again, this is a 23-bit subnet range because we've used 23 bits within those octets. All right. Now let's get wild and crazy and say this is the Wi-Fi scenario. Everybody bringing their own devices, etc. You've got a 23-bit range. That's over 500 available IP addresses. But with so many people bringing their devices in, your organization has exploded and opened up to the public, courtyard, etc. And everybody brings in their Wi-Fi devices, and you are far exceeding your 500 available IP addresses. What do? Well, we can borrow. There goes my black pen. We can borrow from this octet now. And instead of a 23, we have a 22-bit range. Why 22? 8 plus 8 is 16 plus 1, 2. So you go 16, 17, 18, 19, 20, 21, 22 bits used. And the last two are not used. But just like the 23-bit range, where it went 10.4.10.1, 2, 3, 4, 5, 6, 7, 8, 255, bing, falls over to 10.4.11.1, 2, 3, 4, 5, 6, 7, 8, 254. We now go up to, you guessed it, 12. Yeah, that's a lot of numbers. Let's see. I think it's 1021. All right, so guess how many hosts you have now available to you? 1022, because the other was 511. This is now 1022. It just doubles every time you use one of these octets. You're borrowing 255 available IP addresses from that octet. From that octet, as you keep moving down the range and your available hosts get bigger and bigger and bigger, and you keep utilizing, this is the number, the third octet that just keeps rolling over until it reaches the last number in that network range. So in the 22 range of 10.4.10.1, it goes all the way up to 10.4.12.254. I hope this is making sense, because we're going to get a little bit more crazy. And we've decided that we need less than 254 available IP addresses. So we're going to say, boom. Oh man, we borrowed one from the host side. Well, what does that mean? It means that all of this is network. And what does that look like on a subnet mask? By the way, a subnet mask, 255 dot, let's say a 22-bit subnet mask. So we go back to this guy. Okay, go back to the 22-bit subnet mask so I don't confuse you. That looks like this. So 255, take away 3, because you have 1 plus 2 that's been used, or that's been freed up. So 252. So that's what a 22-bit subnet mask would look like. And a mask, again, dot zero. And a subnet mask, again, it masks over the octets that are not available. In other words, do not use these things. It's like when you're spray painting, you mask over whatever you don't want to get spray paint on. And so the same is with the network. All right, so now let's jump over to this. Got this, 24-bit, 25-bit range. We've just gotten super crazy. Boom. All right, what does it make this? 128. Again, because this number is tallied up with the bits that are in use down here. So for instance, if we were to do this one, it would be 194, because 128 plus 64, oh, excuse me. Sorry, give you misinformation. All right, so if we were to do this, it would be 192, because 128 plus 64 is 192. So this signifies the bits in use. Really, the computer doesn't see these numbers. The computer just sees the ones that signify what bits have been used. So it sees 1, 1, 1, 1, 1, 1, 8 ones, 8 ones, 8 ones, 2 ones. These numbers are for us humans, so we can know, okay, so 255, that means it's been used. 255, been used. 255, it's been used. 192, which is 128 plus 64. First 2 bits have been used. Again, this is CIDR notation. There we go. Update my CIDR notation for you. So instead of 24 bits, 8 plus 8 plus 8, 24, we have 2 more bits, 25, 26, which equals 192. By the way, which in this case, how many IP addresses are available? How many hosts are available now? Well, let's tally this up. 1 plus 2 is 3, plus 4, 7, plus 8 is 15, plus 16 is 31, plus 32 is 63. So we have 63 available hosts on a 26 subnet range. Another side note, it's kind of fun. Watch this. So for those of you who kind of like math and like patterns in math, 1 plus 2 is 3. 2 plus 3 For those of you who kind of like math and who like patterns in math, 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 8 is 15, 15 plus 16 is 31, 31 plus 32 is 63, 63 plus 64 is 127. And then, of course, 127 plus 128. One 127 plus 128 is 255. So these mathematical patterns down here kind of give you some of the answers to subnetting issues. Okay, so for instance, in this case, we have 63 available hosts because we've used up the first 2 octets. In reality, you only have 62 because remember, 63 take away 1 because of the broadcast gives you 62. So this down here shows you what it looks like when you begin to borrow from the host side as well. We're changing things to where we only have 63 available IP addresses. And good night, why would you want something so low? You can actually go all the way down to 3 to 2 IP addresses available. Why would you want to do something like that? Well, sometimes you have network devices that you just really want to scrunch down. Maybe, firewall. Several network devices that you know you're never going to get more than that particular number. So sometimes it's nice to limit the number of IP addresses available just for security purposes, for organizational purposes, etc. Done. So this has been subnetting at its very basic level. I hope this has made sense, that it's understandable. One of the things that we could go through is, we'll do this backwards. So when you begin to borrow from the host side, you need to know what to put on the last octet here, okay? Or whatever octet is belonging to the host side. So in this case, we used 2 bits, 2 columns, and that equaled 192. So these are some of the numbers you will have to remember. So 255 is your starting number. Take away 128 is going to be 128. Take away 64, it's going to be 192. Take away 32, it's going to be 224. Take away 16, it's going to be 240. Take away 8, that's going to be 248. So again, it starts from the left, and you start adding all of the numbers up that are in use in order to get that number. Go down to 4, it's going to be 252. Take that one away, 254. And of course, you would never take all of your host IP addresses away. Really, going down to 254 is very limiting, because obviously you've pretty much used up all of your IP addresses at that point. So you have to pay attention to what you're doing. But these are some of the numbers that you're going to have to remember. If you go in for, let's say your CCNA, they're going to require you to know some of these numbers. So 128, 255, take away 128 is 128. 255, or excuse me, 128 plus 64, 192, 224, 240, 248, 252, 254, etc. All right, I hope some of that made sense. I hope you understand subnetting a little bit more, that last part didn't throw you too much. When you are creating your subnets and you decide to use a 24-bit range, that is probably the easiest one you can use because it helps you visualize what exactly is being used for network and then what's being used for host IP addresses. And again, this is your subnet mask. It just makes everything a little bit more simple. So I suggest if you're going to play with subnetting, start with the 24-bit range on a Class A private IP range, IPv4 range. Go to a subnet calculator, such as calculator.net. They have a cool IP subnet calculator. You can type in some of the stuff, and it'll actually show you some of the things that are happening. It'll show you all of the bits in use. It'll show you how many hosts you have. It shows you CIDR notation, etc. So you can really start to visualize what exactly happens when you tweak things a little bit. All right. If you have any questions, please feel free to reach out to me. I always try to be available to explain things in more detail if you need it. All right. Until next time.